Hello everyone and welcome to Rebel Way. My name is Saber Jlassi and today we're going to be learning how to create this bird flocking effect. Now this is going to be a two-part tutorial. The first section I'm going to show how to create the rendering shading in Solaris and Karma, and the second part is going to be taught by Jason Slabber, who's going to show a very clever way of creating this flocking behavior just using simple techniques in pops. So let's get started. Hello everyone and welcome again. Let's take a look at the scene and break it down. It's fairly simple. So I have the lake surface, which is simply a flat plane with some ocean displacement, and I have a mountain, a 3D geometry of a mountain that I built procedurally in Houdini. And this mountain here that you see all the way in the background is simply an HDR. I've added a fog, a Karma fog around the entire environment that helps blend in all of this together. This is pretty much a raw render with very little compositing to add just a vignette to darken the borders. Now let's take a look at the scene, and the scene is fairly simple. I'm going to go over how it's done and then provide this so you guys should be able to follow along if you need anything. So for the mountains, I tried to create something similar to the HDR, which has sharp peaks. And I'm not going to be rendering any details, so I just created something that gives me the silhouette that I need. So I started off with a grid and added some overall noise, like so, and then used this pattern called Chebyshev Cellular, which gave me this pattern, and then I overlaid the second one on top with another noise pattern. I overlaid another noise called sparse convolution just to break it down a bit. And then I flattened out the front part. And the way I did this is I used a soft transform. And I'm going to disable all of this so I can select the points easily. I'm going to select this. Actually, before we do this, it's better to create the soft transform while you have a selection so it can set the centroid properly. So I'm going to select the front edge and hit soft transform. And let's plug it here. Enable back my noise. And I'm just going to set this to 0. You can see now we're flattening all of those. I'm going to increase the radius and flatten this out. So 150. That's too much, so let's just set it to 80. And now we have a nice starting area, and then we get into the mountains. It's going to help blend in the ocean or the lake with the mountains. And that's what I did here. And then I duplicated that, scaled it up and moved it, and combined both of them so I have more depth or more mountains in the back. So that's for the mountains. For the lake, I just created a plane, a 2x2 plane. And we don't need resolution when we know we're going to use displacement. We don't need to have a high-res mesh. We just need a polygon or two to describe where the area of the ocean is going to be, and then everything else is going to be handled through displacement. Now for the ocean, we just need to create an ocean spectrum file, and I have an ocean surface here, which is basically a copy of that geometry, just with more resolution so we can see it. I'm going to let this calculate. It's going to take a few seconds, and I'm going to dive inside. So I have a grid here. It's pretty much a square version of my final lake geometry. And what I did is I used the spectrum, ocean spectrum file, and I set the resolution pretty high because I want to capture all the fine details. So 13 is pretty high, but it works quite well when you have a lot of small details that you want to capture. And I do not plan to displace this. I'm going to use it as a bump. I will show where the settings are. So here this is the default ocean spectrum, and I changed the resolution. 11 to 13 will start to give you really high details, and 13 is pretty high. Now to get this to look like a lake, let's do some tweaks here and maybe lower the resolution of my display grid so it's not too slow to preview. So this is the default ocean. I'm gonna set this to 25 because I want a lot of fine details. I'm gonna change it to Philips because it works better with small details. Now you see how it started pinching and flipping the geometry. We don't want to get this as part of the file. We want to make sure that there's no, this doesn't happen, otherwise we're gonna get black artifacts. So we can remove or reduce that by lowering the chop value. So 0.5 looks pretty good. I'm gonna change the amplitude to 0.5 and the wind speed to 1. So this might look like there's not much details, but it's simply because we don't have enough resolution to see all the details. Now I'm gonna take this file and save it to disk as a geo file. I'm gonna call it Spectra 6, and this is my original Spectra file, and I just save one frame and load that in the shader. So that's pretty much it for the scene. The particle simulation is going to be taught in the second part of this video by Jason Slabber, and he's done a fantastic job to create a super clever and efficient way to do this effect without any crazy calculation. So let's go to the log context where I've done all the karma work. So I'm going to dive inside and simply walk through the steps. And like I said, along with the HIP file, everything should be easy to understand. I'm going to disable the soft create. I also change this to Houdini OpenGL. And what I have here is, let me see, I need to make sure that the geometry is visible. So it's imported, and I'm using a scene import to bring stuff from SOPs into Karma or Solaris. And this is my this is the geometry I need, the lake geometry and the mountains. And I have a fog, which I'll explain in a second. And here, this is importing the cameras, and I have an HDR. So let's take a look at the HDR. So this is what it looks like, and it's called Shudu Lake. You can find this on Polyhaven. It's free. It's a free map you can grab. So for the shaders, let's dive inside. Or actually, let's just take a look at the scene. So this is what it looks like, and let's look through the camera. And this is what it looks like. Now we don't have any shaders assigned, and we just need some diffuse for the mountains and an ocean surface for the lake. Now I'm going to dive inside the material library. We create shaders simply by typing them. So I've done a mountain, I've done a bird, and for the ocean surface, we can use the Alt-G shortcut to get the library, and then we can just drag and drop the shader here, and it's called ocean surface. So this is what we need. It's going to allow us to load in a displacement file or an ocean spectrum, and then we'll do all the displacement at render time. Now I'm not going to execute this because it might take a few seconds, and the only option or the only settings I need to change is turn true displacement. I don't want this to be displaced because I want this to be blazingly fast. So turn off true displacement, and that's going to use it as a bump. So no displacement happening. And I'm going to take on add bump to retrace displacement, which will give me more accurate reflection in the render. So that's it for the ocean shader. And for the shader itself, it's just a principal shader or a principal core, and no diffuse, just pure reflective, 100% reflective, and roughness is 0.05, I believe. So that's all we need. And what I've done is, say I create a new ocean surface. I have all these extra stuff I don't need. So what I'm going to do is just dive inside. And inside this part here, it says classic shader. I'm going to create a principal core or a principal shader, whichever you're more comfortable with. They both do the same thing. And I'm just going to connect the layer into the layer and layer to the layer. Now all the wave and coloring and stuff is not going to affect us. And we can just set the shader here, maybe 0.05 for glossiness, no diffuse, just reflective. Maybe we increase the the IOR to 1.8 or something, and that's all we need. Now let's do a test render here. I'm going to change it to, well, it's already in Karma, so I'm going to enable the calculation. And I've already assigned the shader, so the birds get the bird shader, the mountain get the mountain shader, and the ocean surface get the ocean. Now it's going to take a few seconds for it to show up because it's running in the background, the ocean spectrum evaluate. And this is a great workflow because you only have to cache the ocean once, and then in the shader, it's going to reevaluate and give you a different pattern. So here I didn't cache the ocean spectrum sequence, just a single frame. And by default, it's going to be super fast. So to slow it down, we can just go inside the shader here under displacement, and there's the time here. We can just divide this by 4, and that will make it 4 times slower or 5 times slower. Now this is rendering live in Karma, and the last thing I want to add is a Karma fog box. So you can type in Karma, and this is just a VDB that you can scale, and I'm gonna show you from different angle. So this is my fog volume, and I hit enter. You can see I have a uniform. I have controls to scale it, and I made it bigger than the scene all the way to just left out some parts here, so they are super dark. And if I look through the camera and disable this, this is my fog. We can control the, let me copy this. We can play with the density, make it super dense, and we can control the shadow density separately, so we can have more dense environment but it lets light through more, or we can make it less dense, increase shadows. So there's a lot of control here, and the great thing is I'm using this to actually change how the light, how much light is reaching the surfaces. So that's why I'm getting this nice blend, because it's actually changing the illumination of the HDR. And you can see without this, it's just a typical 3D render. With the fog, everything blends in nicely and it feels much more realistic. Now the last piece is to add the birds. And I'm going to enable that. And again, this is just a simple shader. And looking at references, almost you get this black spots flying in the scene, and that's what the look I was going for. Now there's one last thing I want to show, is because I wanted to make this look a bit more realistic. You can see as they come, as they change direction, you can see the points are getting thinner and wider. You can see here. And that's because they have an actual geometry that represents somewhat a bird silhouette. So I just created something like this. And then because we have a normal and velocity, we can orient that geometry along, and we get this shape. And that's just gonna, once it when it's facing the camera, we're not going to get illumination. It's facing away, it's going to capture more light, so we get a nice change in the point size. And you know, when they're grouped together, we get more, we get denser and darker. So that's the effect. And then this is the particle sim, which Jason's going to explain in a second. Right, I think that's it for this scene. Let me show the settings, final settings. I used no diffusion, no indirect, no global illumination, no motion blur, nothing. Under the advanced tab, I changed the sampling to path traced, and I used 196. That's all I did. And then I rendered 360 frames, and it took about 5 minutes per frame to render, which is fairly fast, to be honest. And this is the render again. And I'll leave you guys with Jason, and good luck. Talk to you soon. Bye-bye.
Hey, and welcome to this week's video. Recently I had to create a murmuration of birds for a commercial. Now this was a fairly quick turnaround shot and required me to art direct their placement on screen. So to achieve this, I created a follow object and built a particle system using standard pop nodes. Right, so before we start, I just wanted to take you through my basic understanding of how murmurations work. Just going to hit play here. So essentially the center of the flock is kind of a safe zone, and these outer guys, they're all exposed to potential predators. So what's happening is the birds are trying to get to the center to be safe, and as they come close to each other, they obviously don't want to collide, so they veer off and they spread out again, and then as they're going too far out, they kind of trying to come back into themselves again, and this is really what's creating these interesting patterns. Right, I'm just going to start off with the geometry node and just dive right in here. So first let's create our emitter. For this I just want to create a circle. Let's just put this on the Z plane here, and I just want to scatter some points on here. Right, let's just set this to around about 3000 just for a little bit of interest. It's quite low still, but good to start off with. Now I want to create my little follow object. For this I'm just going to use a single point, so let's create an add node. Just toggle this on. Right, let's just view it. So now I just want to do some basic lazy man's animation. So for this I'm just going to do a sine wave and give it a $F for frame. Now you'll see my point. Let's just turn this on. It's traveling from 1 to -1. It's a little bit slow, so I'm just going to speed this up a little bit. It's multiplied by 2. It's going a bit quicker, but now it's not traveling very far, so I wanted to come further out, so let's multiply this whole value by 5, and you'll see now my point's going out to 5 and -5 on my grid here, which is pretty decent. What I'd like to do now as well is just visualize this a little bit better. And for this, here's another little lazy man's hack. You can use the rig viz, which is basically just copying this visualizer to the point. If I up the scale, you can see now I've got a little neat little visualizer. Right, so that's cool. Now let's just go ahead and create my popnet. Particle network, let's connect my emitter up to the first one, and I want to add my follow object to the second input here. Just going to view this, and I'm going to dive right inside. Right, so here's the basic setup. So just before I start with this, I just wanted to show you there is a pop flock that ships with Houdini, which isn't too bad, but it obviously doesn't have the follow object that we need, so it's kind of not really what we want to use currently. But what you can do is if you allow editing of contents, and if you dive inside here, you can see how it's been built. So this is just basically a pop attract and a pop interact. Now what's interesting about this, there's some values that aren't connected. So like for instance this velocity force, which kind of averages out your velocity positions, and I'm not too sure if this is a bug or if it's just a not connected setup, but it's not really working for our needs, so I'm just going to go out and delete this. Then what I'm going to do is just trash out this pop wires into here. I never work like this, I always just work from a top-down approach, so I'm just going to trash this out. Okay, now from my emission point, I'm going to go to source. I want to use those incoming scattered points, so I'm going to use all points, and that's first context geometry. For my birth, I just want to birth on one frame, and for this I like to use $simulation frame equals 1. Simulation frame means that any frame your simulation starts on, it will start on that simulation frame if the frame equals 1. It's just a little bit easier than using the $F equals 1, because then you might change your simulation time and then your simulation doesn't really start when it's supposed to. Right, so moving on, I just want to go to the attributes tab. I don't have an incoming velocity, so I'm going to set an initial velocity, but I want to make this like super low, so let's just make it 0.8. which is 0.01 or so. So it's like super small. I'm going to go ahead and turn off these guides because they annoy me a little bit. Right, so now we have our basic setup, nothing really happening, just a tiny bit of variance in the velocity. Okay, so let's start off now with the pop follow, and so I'm going to use my pop attract for starters. Let's just name this to follow. Right, for this setup I want to use points, so this allows me to grab the position of the point coming in from the outside. So I'm going to set this to the second context, which is the second input here of the pop net, which is pointing to that add node obviously. And then yeah, so that we'll just have this, basically this whole system will try and follow at one point. Now we just need to change some settings on this. I want to set it to follow, just gives me a little bit more parameters to play with. Right off the bat, I'm just going to go and set the force to 10. I know for the scene scale I need to bump it up a bit more. You'll see nothing's really going to happen yet. What I need to do is I need to set an ambient speed for the particles generally to move to, so just set this to 1 for now. And you can see I'm starting to get some motion happening. Now obviously I can't really see my little follow object, so let's just sort that out quick. I'm going to jump out of the pop net here. And what I want to do is I want to lock this pane to this current viewport. So if I dive right in, I'll still see this area. But then what I also want to do is I want to control click on this fizz rig on the template. By control click, you can now see it. Let's just change the color here a little bit. Override joint color. It's preferred color, yellow. There we go. So now we can see. So now if I dive back in here, you can still see my visualizer. And you can see the follow object's not really working too well yet. So what I want to do is just start messing with these settings. So I want to bump up the speed scale a bit. Now you can see it's really starting to do stuff, but it's going way past. If I mess with the ambient speed now and I set this to 5, see now it's like, oh, it's going crazy all the way around here. So this is obviously way too much. So I'm basically just going to dial down the ambient speed a bit because I don't want it to follow 100%. Just want it to feel a little bit more organic. Let's just take this down to 2, and I'm going to take the scale down to 5 again. Now I'm starting to it's not quite hitting the mark yet. Let's just bump my speed up a bit more. It's not too bad. Let's make it 7, this 3. It's not too bad. I think the ambient speed is maybe a little bit high now, so let's make it 2.5. I don't want to waste too much time playing with these settings, but that's kind of what I want. You can see over time it's starting to get a bit too heavy though, so we'll just dial this back down again. Right, 2, I think that's just, I'm going to stick with that for now. It's kind of following but not following. Okay, so let's just move on now. We want to create a little bit more interest, so I'm just going to start off with a pop force here. So this essentially, what I want to do is just create some noise, and this starts to create this kind of these interesting patterns how the essentially birds are flying around. But now the problem I had with the basic pop force is this amplitude here is controlling X, Y, and Z all in one go. So if I want to bump up my force scale, it's basically creating noise up and down. And for the shot I was working on, I wanted to really be able to control the noise a little bit more, only on the X and Z axis. Essentially my birds were kind of hovering over a grass plain, so This obviously wouldn't work when you've got too much noise at this level. So for that, I'm just going to disconnect this quick. I created a little custom force using a curl noise, and for that I used a VOP, pop VOP. Right, so let's just connect this and just dive right inside. So what I want to do is use a curl noise, and I want to just connect the position of the particles to the curl noise. I'm going to be affecting the force, so for now I'm just going to connect force to force. So basically any incoming force will still apply, and I just want to add to this incoming force. So now in order to do just the two planes, what I want to take, this curl noise is giving me a vector, so I just want to change this to a float. So we do a vector to float, and this will basically give me my X, Y, and Z axis in 3 components. And then if I do a float to vector, this allows me to basically combine them again. So I'm going to take my X axis and plug it in, and my Z axis, which is the third one, and plug that in there. And you'll see if I don't connect this component value, which is Y, is set to 0. Now if I add this, let's drop the add node, I'm going to add this noise to my current force. And now you'll see I start getting noise, and it's only really happening on the 2D plane, which is a little bit more what I want. I'm just going to go ahead and change this. I've played around with quite a few values based off, I just want to keep it based off the scene I was using. So for this I used just this analytic simplex noise. I just found it great at some interesting patterns. I just wanted to reduce the frequency a bit. A little bit more swirly, maybe a tad more noise. Not too bad. Let's just reduce the roughness, and I just want to bump up the frequency a little bit more. It's interesting. Alright, so now if I just bump up this amplitude, you'll see it starts going quite crazy, but it's giving me this nice 2D kind of noise. And this is obviously way too much, so I'm just going to make it about 3 for now. That's quite cool, I think. And I'm getting my little follow object. Obviously now this is quite chaotic still. Doesn't have any sort of nice following. It's probably a little bit more like a swarm rather than a bunch of birds flocking. So let's just start adding some extra stuff to this. Right, for now, let's go. I want to, after my pop follow, I just want to do another pop attract. And this is essentially, I want to make little clusters of follow objects. So I'm going to set this to particles, which basically is themselves, and it's got this number of clusters, and the number of clusters currently is set to 1. And let's just show you what that's doing. If I disable this pop follow, let's just disable this noise. Okay, we've got 1 cluster. Let's just bump up this force a bit so we can see really what's going on. So now essentially I've got all the particles. They're trying to get to the center. Obviously this is just 1 cluster. If I set it to 2, you'll see now I've got 2 little clusters, and they're trying to follow, they pick basically one point, and they're trying to follow that point, so they're going off in their own direction, but they're still sort of averaging around themselves. What you can do, and what I found quite nice, is this reversal distance almost creates these hollow pockets, and if you look at the murmurations, you'll see feels like there's a bit of a hollowing, and I guess that's where they're almost trying to avoid each other and not coming too close. So if I bump this up to just give it a random value for now, you see now I start to get, okay, that's a bit higher for this example. So now you'll see I'm almost getting these like spheres of birds, and without them sort of getting to the center, which is pretty interesting. Okay, so let's just move on from here. I can come back to these settings. I'm just going to set this to 1 for the moment. And then let's just enable my force and my pop follow so we can start dialing in some settings. Right, so now you see I've got my noise happening. I've got these like little hollow pockets, these 2 formations happening. The forces might be a little bit strong, so they're kind of separating a bit much, but it's quite interesting for now. So now we just want to start working on them sort of averaging around each other and not getting too close to each other. So this is where the pop interact comes in. Pop interact. Right. So now we'll just immediately see they sort of starting to feel a little bit more uniform in their shape and kind of spread apart a bit. I'm just going to set this pop attract, the goal. I just want to set the clusters to 1 again. It's just a little bit quicker to work with. This gets quite slow the more clusters you have, and I'm only working on my laptop, which is a little bit slower, so just easier to dev with 1 point and kind of get the idea of what's going on. Alright, so let's just dial in some settings here. I just want to up my force, my position force, and this is kind of how strong the particles try and keep away from each other. So you can dial it up now. It's actually becoming a little bit more swarmy again. So it might be a little bit much. Let's just dial it down. Right, and then what I want to do is this velocity force. This is quite cool because this is almost what the birds are doing, is they trying to fly together, so their velocity is essentially averaging almost together. So when you start dialing this up, you'll see now you start getting this, they all kind of really moving at the same speed. That's obviously way too high. We still want a little bit of chaos and a bit of separation, so I'm just going to dial this back down. Let's make it just over 1. So that's not too bad. I'm getting kind of one sphere that's still kind of averaging each other out here. So I'm just going to bump this force up just to see what this does. So they're kind of pushing away from each other a little bit harder. Maybe we can increase this radius, and this fall off radius is just softens it out a little bit as well. So that's getting a little bit more interesting. I'm quite liking that setting. So let's just now go back and look at the pop attract. Let's go to the force tab and see what we've done here. Reversal distance, we could probably set this up higher. Again, just to maybe create a bit more separation. So now they're really spreading out, and they almost like bulge out when they come too close. So that's quite interesting. Maybe a bit much. Let's just make it 1.5. I think this force scale is actually probably a bit higher because it's kind of almost overriding this a bit much. So I'm just going to halve this and see what this does. And you can see now I'm getting a little bit more of a follow action happening again, and still got some separation happening, which is quite cool. Let's dial up this This is really, you start playing around with the settings and just seeing, depending on your scene scale, you know, just to get that look and feel of what you want. That's quite cool. Let's just bump up my clusters to 2 again. It's starting to look quite interesting, getting some interesting shapes happening. Maybe what I can do is try and get them to follow the follow object a little bit closer. So I'm just going to go back to my follow here. I'm just going to bump up this scale a little bit here. This is the overall scale on everything. They're kind of just getting, yeah, they're matching a little bit better now. And there's the ambient speed's quite low, so you're getting these ones almost kind of falling away. If I drop this down, you'll see I get quite a lot of breakup around the edges. So this is kind of, this ambient speed is a nice way to control that sort of overall ambient speed. You see the pop attract is kind of taking over now, but and if I bump this right up, you'll see my ambient speed now. They're all really just going to follow this super closely. So if you really want a tight following cluster around your follow object, just bump up this ambient speed and that kind of works. But for this case, I just want to dial it back down again. So the last thing I want to do is just add a bit of drag into this. So by default, you'll see it's kind of creating drag over all the particles, which isn't ideal. We want to kind of randomize the drag. So for this, we're just going to use a basic fix expression. Just for ease, I'm just going to show you, you can just drag this onto here and you'll get the name of this parameter. Obviously, we don't want the full path, so you can just delete it, or just, if you hover over, you'll see the parameter's name, and you can just type it out. So what we're going to do here is do a randomize each particle ID, and then we're going to fit it to a range using this air resistance. So just a single equal. So we'll do a start off with a fit 0, 1, which kind of is a fit range between a 0 and 1 value. Then I'm going to get my random ID, and then so now I've got a random ID which gives you a random value between 0 and 1. I just want to fit this to, let's just say 1 and 0 for now. Let's hit play. Let's see, it's still got quite a lot of drag on some places and no drag. You can see some of these particles moving quite fast, so those don't have any drag. This is like really high, so I just want to create a really small value, just to vary it up a little bit. And I think that's pretty much that. I'm happy with that.